Hi, and welcome to the course Machine Learning with Lego Bricks. As you may have noticed, artificial intelligence is everywhere these days. Your phone recognizes your face, your email filters out spam, and your streaming service somehow knows you want to watch another baking competition show. Cool stuff, isn't it? But understanding how these systems actually work is where most of us hit a mental brick wall. That's why we have created this course, which doesn't require any programming experience or advanced math skills, because here we focus on the basic ideas of machine learning and do it interactively using this LEGO Spike Prime Kit and the web platform that we have developed exclusively for this course. You can either simply watch the course or actively engage by doing the experiments as you follow the video. For the hands-on approach, you will need 5 bananas, 5 apples, an orange, a table tennis ball, a LEGO Spike Prime Kit, and your Bluetooth-compatible device. During the course, we will build 3 robots in total. One that predicts foods, one that serves balls straight to the target, and one that learns how to crawl with its arm. Before that, we need to cover some theoretical basics that will help us understand what's happening under the hood. But no worries, it will be simple and short. Let's begin with the question, what machine learning actually is. First, machine learning is a subfield of artificial intelligence, and in fact, a very large part of artificial intelligence is either machine learning itself or machine learning driven. Secondly, and most importantly, machine learning is about learning patterns from examples. What does that mean? For instance, if we show the computer many examples of pictures with dogs in them, then we also show many examples of pictures with cats in them, eventually the computer will be able to tell whether a picture shows a dog or a cat. What machine learning is not, however, is giving the model some instructions instead of examples, such as dogs have longer snouts and appear stronger, cats are slimmer and have pointed ears, and then asking what's in the picture. That is not machine learning. Machine learning needs examples to learn. A reasonable question might be, why do we even need machine learning at all? We can distinguish cats from dogs by ourselves. And the answer is the same as with all previous revolutionizing technologies, such as windmills, computers, electricity, engines, and so on. Because it allows tasks to be automated, and because it can outperform humans. For example, if we wanted to predict the weather in Munich tomorrow, to ensure accuracy we would need temperatures, wind speeds, and directions at many points around the world. We would also need historical trends of these variables. That is a lot of numbers for an ordinary person to get lost in, not speaking of predicting something from them. But we successfully use machine learning to do it for us. Machine learning analyzes all these numbers just for our phones to tell us that we shouldn't forget an umbrella tomorrow. Okay, weather forecasting is nice. What are other applications? There are many of them. We can build self-driving cars, we can predict whether a person has a disease based on details that are not even visible to the human eye. We can build robotic arms for different tasks, and even conversational bots use some methods from machine learning. And all these algorithms have one thing in common. They all need examples to learn from, because as we said, machine learning is learning from examples. Now, let's break down what these examples consist of. First, we have what we call features. These are the things the computer will use to make predictions. Features are like the clues or information we feed into the predictor. To predict whether it's a cat or a dog in the image, features are the images themselves. Second, we have labels. This is what we are trying to predict. In this example, the labels would be cat and dog. The predictor that uses features to predict labels is called a model. And when we take features and their corresponding correct labels combined together, it's called data. To take another example, we can try to predict how cool a Lego set is. We could use features such as the year the set was made, the number of pieces in the set, and some specific features such as whether the set is programmable or has a theme such as Harry Potter or Star Wars. As a label, we grade how much fun we will have playing with the set on a scale from 1 to 10. It's also important to note that we should take features that will help us predict the label. For instance, if we took something like the set's product code number, like here it's 45678 or 10305, This wouldn't really help us predict how fun are we going to have by playing with this set. These numbers are just random identifiers that don't tell us anything about the set itself. Therefore, we should have a logical connection between the features we use and the labels we want to predict. With this being said, we are ready to build the first device and empower it with machine learning. To do this, you first need to connect your Lego Hub to our web platform. In the next video, we will explain how to do this. See you there!